Today we are going to work toward identifying the properties of the frictional force. So friction is a property of two materials that slide or move past one another. It's not always sliding, but as they move past one another, there are different types of friction. So the coefficient of friction is represented by the Greek letter mu, and I will draw that in just a second. So the Greek letter mu looks like that. And so friction is a reactionary force. That means that even though it can reach a certain force, it won't actually get there unless another force reacts to it. So if the frictional force is calculated as something like 50 newtons, but there's no push on it, then it doesn't have anything to push back against. So you can kind of think of it as like a budget. So there's a maximum amount of friction available, but it may not get to that amount. So if the primary force does not reach that level, then the friction will only rise up to that level. But if it exceeds that level, it becomes more than the force due to friction. That's when you'll have movement and a net force. If they're equal, this is equilibrium, which we have talked about before. There can be movement during equilibrium, but it can't move from rest unless there's a net force. So we have a new equation. It is the force due to friction is equal to mu Fn. The force due to friction we've seen before, this symbol. This is the force due to friction here, F sub F. And mu is the coefficient of friction. And F sub n, you have seen before, this is the normal force. Remember, the normal force is the supporting force. And it's usually, well, it is perpendicular to the surface. So it's perpendicular. Okay. So there's two types of friction that we talk about, in this class. It's the amount of friction. So there's static friction, which is the amount of friction when surfaces are not moving relative to each other and then start moving. It's always higher than kinetic friction. And we consider rolling as a type of static friction because the tire, say it's a wheel, the tire is here, and then that's just to identify where on the wheel it is. And then the new bottom of the wheel is here, and that dot has moved. So we consider rolling a static friction in this class. There is actually a rolling friction, but we don't talk about it in this class. We just use the static friction. Now, the other type of friction that we talk about in this class is kinetic. This is the friction between surfaces that are sliding. Okay, so here's a friction problem. We have Miley Cyrus wears a satin dress while dancing the salsa with Robin Thicke, who is wearing cotton jeans. If she applies a pressure of 11 newtons, the normal force, and needs 4.73 newtons of force, the force due to friction, to slide past him, what is the coefficient of friction of satin versus cotton? Now, mu, this is the coefficient of friction. This changes based on the materials. So we have satin and we have cotton. So we want to find mu. Right? So the force due to friction is equal to mu Fn. This is in the reference table. We have the force due to friction from the previous problem, and it's equal to mu times the normal force. So we just plug it in and we get 0.43. Notice there are no units on mu. This is because when you work this out, you have 4.73 newtons is equal to mu times 11 newtons. If you divide that, you get rid of them, so there isn't anything. Almost always, mu will be less than 1. As it goes up in, as it gets closer to 1, it gets stickier and stickier. You can go above 1, but it's really hard. All right, thank you.